OpenVPN allows you to create secure point-to-point or site-to-site connections. In this video, we will use OpenVPN to connect to the private AWS VPC. We will create a few private and public subnets, and later we will push those routes to the clients. Also, we will create a private Route 53 hosted zone and push the AWS DNS server to the client. This will allow us to resolve those private hostnames locally. In the first example, we will create an OpenVPN profile manually. In the second example, we will create a simple script to automate profile generation. In the last one, we will use the open source gate-sso project to use Google single sign-on to automate cloud certificate and profile generation. Let's start from scratch. First, we need to create an AWS Virtual Private Cloud (VPC). Let's call it main and give it a seeder /16. It will provide you with 65,000 IP addresses. Now, to create a public subnet, we need to have an internet gateway. Let's create one and attach it to our VPC. Next, let's create a public subnet with a default route to the internet gateway. We will use that subnet to place our OpenVPN server with a static public IP address. You can keep no preferences for the availability zone. I will place all the VMs in one zone for this demo to avoid data transfer charges between different availability zones. I will intentionally create all the subnets with different seeders to show you how to configure the OpenVPN server to push routes to the clients. This one /22 will have 1000 IP addresses. Now the public subnet needs to have a route table associated with it with the internet gateway. Let's call it public and select our VPC. We're going to update routes later when we get to the NAT gateway. For now, let's just attach it to the public subnet. Allocate static IP address for the NAT gateway. NAT gateway will allow VMs in those subnets with private IP addresses only to reach the internet. Now we can use this IP address and create a NAT gateway itself. When you select a subnet, you must place NAT in the subnet with the internet gateway, in our case public subnet. Time to create a couple of private subnets just for the examples. Let's call the first one private large and allocate 4000 IP addresses. For the second private subnet, give the name private small with only 256 addresses. Now we need to create a private route table and use NAT gateway as our default route. Click Add Route and add 000/0, which means everything that doesn't match a more specific route, in this case 10.0.0.0.16, the local route within VPC will go to our target NAT gateway. Let's do the same thing with the public subnet, but instead of NAT gateway, use internet gateway. Finally, update route tables on private subnets. Instead of the main route table, use the one that we just created. Let's quickly check that we have correct route tables associated with our subnets. Next, let's allocate a static public IP address for our OpenVPN server. If you decide to simply use public IP address that auto-assigned to the VM when you boot up the virtual machine, when you stop or terminate that instance, you may lose that IP forever. We add those tags just for our convenience. When we get to the point when we need to associate that IP, it's much easier to find using name tags. Let's call it simply OpenVPN. Now that IP will belong to us. Keep in mind for the time that IP is not attached to any EC2 instances or network interfaces, you will be charged for that IP. Time to create EC2 instance. Let's search for the latest Ubuntu with a long-term support. At this time it is Ubuntu 20.04. When you're just getting started, you don't need to have a large instance. You can always increase the instance type at any point. Depending on your workload, the main thing that you need to watch out is traffic, because AWS will charge you if you exceed a certain amount per month. It's crucial for the production environments that you understand exactly all the charges that AWS will place on you. Knowing the cost can and should affect the way you build your infrastructure and the applications. I'm going to pick T3 small instance type for this demo. Here it's very important to place your OpenVPN server in the public subnet with the internet gateway. Then make sure that you disabled auto-assigned public IPs. That's all configurations that we need here. Keep default 8 gigs of storage. Same thing here with the tag. Give it a name just to simplify your life and try to keep those names consistent. We need a new security group. Let's give it a name OpenVPN. That will be the only one instance in our infrastructure that will be open to any source to SSH. When we deploy our OpenVPN server, we will use this security group as a source for any other EC2 instances that we want to SSH. I'll show you an example later. Then we need a UDP port for our server. You may want to use TCP in some situations, but it's generally recommended to stick with UDP. I'll attach some links for pros and cons. 1194 is a well-known OpenVPN server port. You may customize it when you configure the server later. As a shortcut, you can use anywhere. It will automatically fill in all IPv4 and IPv6 IP addresses. For gate-sso, we need to open additional port later. If you don't have a key pair or you want to use a new one, select create a new key pair. You can choose either old RCA key or new elliptic curve, which allows you to use smaller keys and in general faster. Give it a name DevOps and download a private key. Let's wait a few minutes till the EC2 instance transitions to the running state. You can see that we have only private IP for now. Let's go to the elastic IP addresses and attach our public IP address to this instance. Choose the OpenVPN EC2 instance and select the private IP. In AWS, the public IP address is not exposed to the VM itself, it's knotted through the private IP address. Now you can see the public IP address. Before we can SSH to Ubuntu, we need to restrict who can access the private key. The default user for Ubuntu 20.04 is Ubuntu, and also let's grab our public IP from the console. The first step is to update default Ubuntu repositories. Before you install any Ubuntu package, you can check the candidate version by running apt policy and then the package name, in our case OpenVPN. Default Ubuntu repositories contains 2.4.7 version, which is not the latest one. If you want to use the latest version, the best way is to use official repositories provided by the vendor of the software itself and not the standard packages. Let's see what versions are available now. If you go to the OpenVPN GitHub page to the tags section, you will find that you have a newer version 2.5.3 that you can install instead. Let's do that. Since we would need to run a few commands with a sudo access, it's easier to become root for a while. First, let's add a GPG key that is used to verify the integrity of the downloaded package. Then add the OpenVPN Ubuntu repository. It's a best practice to create a separate list. Let's update the index again and let's see what candidate is available now. Alright, we have a new version available for installation. Optionally, you can use equal sign to specify the exact version. Next, we need some kind of tool to manage our PKI, public key infrastructure. It's very common to use OpenVPN with easy-rsa since it's a tool built by the OpenVPN community. But you don't have to, you can use something like CFSSL or any other way to create and maintain your certificates. You can even simply use OpenSSL. The same thing with easy-rsa. First, let's see what candidate is available and also let's check the latest release. Okay, it's 3.0.6. If you go to GitHub, you will find a newer version 3.0.8. Let's just download the tarball and put it on the path. Now we have the tar and the folder with easy-rsa. Let's clean up a little. It's common to place easy-rsa under OpenVPN. I would suggest following the same locations, since we will use this tool later to automate certificate generation. Optionally, you can create a soft link to the user local bin. Let's just make sure that easy-rsa is available and ready to use. The first step to manage public key infrastructure with easy-rsa is to initialize the folder structure for keys and certificates. We can create vars file to customize the certificates. You can provide some common variables such as country, province, and others. I think the only one that you need to pay attention here is a type of the algorithm. We will use elliptic curves. Elliptic curve cryptography provides more security and eliminates the need for a Diffie-Hellman parameter file. I have to warn you at this point, if this private key is stolen, anyone will be able to issue a certificate and connect to your OpenVPN server. You need to decide for yourself how securely you want to maintain your CA. You may decide to keep it offline and only access it when you need to sign a new client or server certificate. The biggest security hole here is to omit a passphrase when you generate a CA. It is a password that you need to provide each time when you sign a certificate. For this demo, I will omit passphrase just to automate the certificate and profile generation with gate-sso. In general, it's a terrible practice. Anyway, let's generate one. Confirm the command name, it can be anything related to your company. It's done, we have a new CA cert located under PKI directory. All the private keys, including the CI key, will be stored in PKI private folder. Since we will use public key cryptography, we need to generate certificates both for the server and the client. Let's make one for the OpenVPN server first. Same no-pass flag to skip passphrase. In the case of the client-server certs, it's a two-step process. First, generate key pair with a certificate request, then you need to use CA to sign that certificate request and issue a valid certificate. To sign, use signRec command. Alright, we have our first certificate. The next step is to create another secret that is not related to PKI. It's called TA key. This is kind of like a crypto firewall. Each packet going over the internet will be signed using a shared secret on both servers and the clients. When OpenVPN receives a packet, it will calculate a signature and check it against the signature provided in received packet. If it doesn't match, OpenVPN will drop the packet. When coupled with UDP, this can be a good way to avoid troubles with port scanners, as it will not see OpenVPN port at all. This feature is also a good way to protect yourself against unknown bugs in the SSL library or protocol, as it reduces the attack surface to only your own users. Enabling TLS authentication is highly recommended. This secret needs to be securely copied to all OpenVPN clients and servers. To properly function, we need to make sure that IP forwarding is enabled. By default, it is commented out in Ubuntu 20.04. We need to remove the comment and enable it. We also need to configure IP table rule to use the server as a NAT to translate client IPs to OpenVPN server IP. That's a reason why we use the OpenVPN security group as a source for any instance in our VPC. Let's list some default policies. By default, they are all set to accept. Some tutorials using high-level firewall tools such as UFW. If you enable it, it will create a bunch of rules. For this tutorial to be as much as possible transparent, I simply want to add a single IP table rule. First, we need to find the default network interface that is used by the server. It will be ENS5. Create a NAT rule that will translate all the source IP coming from this range 10.8.0.0/24 to OpenVPN Ubuntu server IP. This range is a virtual network that we define later for VPN. All the clients and OpenVPN server will get IP from this range. If you are using plain IP tables, you need a way to save them and reapply those rules after reboot. One way to do that is to use the IP tables persistent package. It will ask you if you want to save your current IP tables IPv4 rules. You should say yes. For the second one, IPv6, we don't have anything. Time to configure the OpenVPN server. This will be the main configuration for the server. First, pick a port. The default OpenVPN port is 1194. Then you need to select the protocol, either UDP or TCP. Generally, UDP is recommended. I'll attach a link with explanation. We need to choose between TAP or TAN devices. Same here, you will find a link, generally stick with a TAN device. You want TAP if you want to transport non-IP based traffic or IPv6 traffic on OpenVPN 2.2 or older releases, or you want to bridge. Next is the location of the CA certificate. You can use relative or full path here. You can even insert your cert in line in the config. You'll see when we get to the client profile. Then the location of the server certificate. Private key. Then we can disable the Diffie-Hellman parameter, since we're using elliptic curves. Then the secret that we generated to check each packet signature. The value should be 0 on the server and 1 on the client. The cipher to use. Auth used to authenticate received packages. Virtual network config, IP range and a mask. It will be /24. It will give you 256 hosts. That's how many clients you can connect at the same time. You may want to increase if you wish. Location to save records of client virtual IP addresses. Then ping-like messages. Optionally, you can reduce OpenVPN privileges. Just make sure that you have nobody user, otherwise OpenVPN server will fail to start. Same thing for the group. Few more parameters. Status location. This can be used by Prometheus exporter to extract current usage and visualize it in Grafana, for example. Network topology, set to subnet if you don't need to support legacy Windows clients. Then the most important part of configuring the server. You need to push routes to the client of the available subnets in AWS. If you remember, we created the public subnet 10.0.0/22, which translates to 255 subnet mask. This particular route needs to be pushed if you want to access the private IP addresses of VMs in that public subnet. Next, route for private large subnet with a 240 subnet mask. 10.0.32.0 is a private small AWS subnet. Then we want to be able to resolve private route 53 hostnames. We need to push the DNS server IP address to the client. Route 53 DNS IP is always your VPC seeder plus 2, which in our case is 10.0.0.2. Let's quickly check if you have nobody user and no group. Use systemctl to start OpenVPN. Check the status for any errors. It's active and we don't have any errors in the output. Enable just to automatically start after a server reboot. If your OpenVPN fails to start, the best way to find error in the logs. You can use the journalctl command and filter by unit name. Looks good, let's continue. Now let's create our first client profile. We need to generate a client certificate. You need to pay attention to the paths. We will use them later to extract certs and keys. Let's sign it. Let's create a profile with OVPN extension. You can then install OpenVPN client such as TunnelBlick on Mac and double-click this file to import it. We need to indicate that it is a client profile. Same TUN device as in server. Most of these parameters must mimic configurations in the server. Since I already go over most of them, I'll skip it. Here you can use the public IP address of the OpenVPN server, or you can create a DNS record and use that hostname. I'll add some scripts that need to be uncommented out based on the system. If your Linux machine doesn't use a system resolver, use the first one, otherwise the second one. If you're on Mac or Windows, you don't need it. Then we need to include certificates and keys. You can use file path or you can include certs directly in the profile. First, for certificate authority, you need open and close tags. Let's paste the content inside. Same thing for the client certificate. Private client key. And finally, that TA key that we created with OpenVPN. Now let's install OpenVPN client. If you're on Windows, you can use the official OpenVPN client. If you're on Mac, TunnelBlick is the de facto default open source client. Let's navigate and double-click the profile. You can get this configuration panel if you click on VPN details, or you can use the drop-down menu to connect to the VPN. Select the profile that we just imported and click connect. Let's open the server logs just to see if we get any errors. It will help to debug. You might get the warning that your public IP was not different. This setup is not used to hide your public IP, it is to be able to connect to your private AWS VPC. If you want to hide your IP, it is possible to route absolutely all network traffic over the VPN. You need to add a server push directive, push redirect gateway def1, and on the client redirect gateway def1. In the server logs, you can see that the example 1 client is connected. Also, just to debug, you can list your network routes on your machine. On the Mac, you can run netstat-r. Here we have all the private subnets and public subnet routes pushed to the client. It's a very similar setup on GCP, you just need to use different DNS server IP and push that route as well. Let me know in the comments if you want me to set up OpenVPN in GCP. To test the connection, let's create another EC2 instance. Put it in the private subnet. Here's an important part. Now you can use the OpenVPN security group to grant access to the EC2 instances. If you just want to SSH, get the OpenVPN security group ID and replace the source. This will significantly improve your infrastructure security, since those ports will be open to VPN clients only. Let's wait a little bit and try to SSH to that server private IP address. You must be connected to the VPN. Alright, we successfully SSH to the new EC2 instance using only private IP. Now let's create a private Route 53 hosted zone. You can give any name you'd like, let's call it devops.pvt. Select private hosted zone and select the VPC. Create a sample record to test DNS resolution. You can give any IP address, it's just for the test. While we're still on VPN, let's try to use dig to get DNS records. It may not work, you can see that we didn't get the IP address. For private zone to work, you must enable DNS hostnames and DNS support. Let's check in AWS console. Also check if you have the correct DNS name server. On Mac, you can open network settings. Under DNS, you should see the AWS DNS server 10002. First, DNS resolution, it's already enabled. Then hostnames. You need to check the box and save it. Then you may need to wait for 5 or 10 minutes before you can resolve that test hostname. Alright, we got our IP. Let's disconnect from the VPN. Next, I'll show you how to revoke access to the VPN. You just need to revoke the client's certificate, generate the certificate revocation list, and update the server config. You have the warning that you also need to generate CRL with the gen-crl command. Keep a note of the location. Let's add this to the OpenVPN config on the bottom. Save it and restart the OpenVPN server. Open logs to see the error message. Now let's try to connect. You're going to get a timeout in about 60 seconds. On the server, you can see that the client certificate was revoked and a TLS error. On the client, you will see an error as well. Let's cancel it. Now let's create a simple script that can help to generate client profiles. Create a client configs folder to store profiles. Then let's create a base profile. Exactly the same parameters as before. You can still generate certificates manually and use a script to populate your profile, or you can include this step as well in the script, it's up to you. Create key pair and sign that cert. Create gen client profile sh file. Define folders with keys and certs. And then just use cat with the base config and insert certificates and keys. It's pretty much the same as we did with the first profile, the script just automates it. Now make the script executable. Run it with the profile name, it must match the certificate that you created before. Let's cut that generated profile. Let me just copy it from the server and paste it to the Visual Studio. You may want to use secure copy command to copy files securely. You can double-click and import it. Alright, we successfully connected. Just a quick check, use dig to verify the VPN connection. It has to be able to reach a private AWS DNS server to be able to resolve it. Works. The last example will help you to automate profile generation using Google Single Sign-On. This is by no means a production-ready setup, it's just to demonstrate the basic concepts. First, we need to install Docker on that Ubuntu server. We will use Docker to run MySQL container. You can find all the commands in the README file, the link is attached to this video. Add Docker repository. Then install the Docker. Let's also use Docker Compose to define the workload in the YAML instead of using Docker CLI flags. For the gate-sso, we need to use MySQL 5.7. Create a volume to persist data between restarts. You may want to consider RDS or a dedicated database installed on a separate VM for production use. Also map port from the container to the local host. Create environment variable to set a root password. To start, run Docker Compose app with a -d to run it in the background. Let's check if the MySQL container is up. We need to install the MySQL client and configure the user inside the database. If you just run apt install MySQL client, it will install the client for MySQL 8 server, but it still will work for us. Let's connect to the server. Use 127.0.0.1 instead of localhost. It will use a different connection mechanism. Create gate user with DevOps123 password. Grant access for development and test databases for initial tests. Gate-sso is a Ruby on Rails app. We need to have Ruby installed to be able to run it. Right now it's missing. We need to install a certain Ruby version. To do that, let's use RVM. First, you will get an error. You can fix it by importing the GPG keys. Then rerun it. gate-sso was developed using 2.4.3 Ruby version. You can find it in the source code. Install the bundler gem. Now we need to clone the gate-sso project and install dependencies. Run bundle install. If you get an error, you can fix it by installing missing packages. Let's rerun bundle install. It also requires Node.js runtime. Let's install it as well. Now initialize by running rake app init. We need to update few variables in the env file. First, gate URL. We will use HTTP here, but I highly recommend running Nginx in front of it and getting a TLS certificate from Let's Encrypt for production use. Gate.devosbyexample.io will point to the public IP address of the OpenVPN server. Now, client ID. To be able to configure Google Single Sign-On, you need to have a GCP account. I have already created the GCP project. You need to navigate to API and services and create auth consent screen first. I already created it, but it's very simple. Let me click edit. Just give it a name and email. Later you can customize if you want. When you finish with the consent screen, create a new set of credentials. It has to be a web application type. Add redirect URI. Here it has to be your domain. Users of Google callback will stay the same. Copy your client ID and the secret. Update domain and add your Google org domain. If you want to grant access to anyone outside of your organization, you need to secure that URL with HTTPS and mark it in GCP as external. MySQL host and a password. we need to create a public DNS record for the gate. Before you're going to run it, run setup. It will run few tests. Let's open port 80 on the OpenVPN server. Gate-sso will not generate your profiles, it will only invoke a couple of the scripts. Let's create them and launch the app. The first script will be run if the client doesn't have a key pair yet. I'm not going to go over each line here, just keep in mind that you can use any PKI tool, not only easy-rsa. The second script will be run if you already have a private key and you want to generate a new cert. For example, it was expired already. Now let's run it. For production, you want to run Puma and bind it to the Unix socket instead. Then in Nginx, you can use that Unix socket as an upstream server plus secure it with a certbot and let's encrypt. Finally, let's go to gate.devopsbyexample.io and try to generate the profile. Click on Sign in with Google, choose the account and then just click Download OpenVPN profile. You have all the necessary files in that folder: CA, certificate, key and the profile itself. Double click to install it. Go to the terminal and test the VPN. It works. Let's also SSH to the server using a private IP address. That's all for this video, and I'll see you in the next one.